Hi friends, welcome back to the channel. This is a video from the series of lectures on practical thermodynamics where we see practical engineering problems from the topic of thermodynamics and we see how to solve them. So in this video we will be addressing the differences between system and control volume. First, we will go through the definitions and later I will pose a few questions to you. Finally, we will discuss the answer for the same questions. Make sense? So, without much ado, let's get started. So, everybody may be knowing this definition. The word system refers to a fixed mass with a boundary. However, with time, the boundary of the system may change, but the mass remains the same. Makes sense, not that difficult to appreciate. Now let's see the definition of a control volume. But before we go ahead, there are a few key words in this definition. One is the fixed mass, and then there is this very important keyword that is boundary. But with time, the boundary of the system is allowed to change. Now let's go ahead and talk about control volume approach. In control volume approach, we do not focus our attention on a fixed mass of fluid. Instead, we establish a window for observation in the flow. And this is what we call the control volume. Here, there is no fixed mass, but here we have a window of observation. Now, across the window, mass, momentum, energy, all are allowed to cross or all are allowed to transfer. Make sense? So, in fact, there are different variants of control volume definition itself where they allow this window to change in size and direction. But let us not talk about control volumes of that kind. We will limit ourselves to the simple control volume approach where the window or the boundaries remains fixed. So having seen the definition of both these terminologies, now I have three systems shown in the screen for you. I would like you to classify this as either a system or a control volume. Whether in each of these three cases you can comment your answers. So you can pause the video, you can think yourself and then come back with an answer. Otherwise, you can see the rest of my video. So the first example is sand in a sand clock. It is clearly a system because the mass remains the constant. Now coming to contents in a closed flask, this will also fall under the category of a system because the mass remains constant. Now coming to the very interesting example, the third, air inside the tire being inflated. Which category does this example fall to? The answer is this particular system doesn't categorize as either a system nor a control volume because the mass is changing as we are pumping in more air. And at the same time, the volume is also not constant. The volume is also changing, isn't it? As we pump in more and more air, the volume changes. So this doesn't qualify as neither a system nor a control volume. Make sense? If you have understood the concept from the last question, you will be able to answer this correctly. Now, to what category does this system fall to? Filling of a gas cylinder. I have shown a gas cylinder here. So this is a control volume because here the volume is not changing. There is mass transfer across the boundaries, but that's fine. Here the volume remains same, so we can consider this as a control volume. Make sense? Our final question for this video, to what category does this system belong to? Here we have water flowing through a shower head. This is definitely a control volume because we can consider some volume around here and then there is mass transfer across those the boundaries. Make sense? So to summarize, we saw the differences between system and control volume and we saw some real life systems and we were able to classify them as a system or a control volume. Make sense? So that is what I wanted to convey. Thanks for watching my video.